Hello, can you hear me? Yes, no, maybe so. Oh, sweet, awesome. Welcome. My name is Liv. I'm going to be your guided study group leader for the semester. I see we just got a new person. Can you please, whenever you come into the room, just go ahead and put your PSU ID in the chat. That's the one with the letters and the numbers. You don't need to do your full 9-digit one. And that's just for my bosses so that they know that some people are coming to my sessions. So thank you guys for doing that. I really do appreciate it. So basically the way that this works is that we all kind of come in here into the Zoom room and do some practice problems and work through some of the difficult things that people kind of ran into this week. So yeah, I feel like I'm forgetting something that I usually do at my introductory spiel, but we do this once a week. I record them. I will be putting this recording on YouTube, on my YouTube channel. So when it is posted, I will make sure to put an announcement out so that you guys can see and view this later. That's basically it. Thank you guys for coming. Without much further ado, do you guys want to just get started in 7.1? All right. You guys are still using the 11th edition of Finite Mathematics, right? Because I had some issues in another class where they had swapped editions on me, and I would really like that to not be the case here. Do you guys both have your books? I think that is question number one. I generally do problems, yep, oh sweet, 11th edition, awesome. I generally do problems straight out of the book. So if you don't have your books, it can be difficult. If you don't, just let me know and I'll make sure to write the problems out fully before solving them. If you do, then we don't need to take the time to do that. So let's get started with number 2. We're in 7.1 and this is on page 363. So basically they give you a couple of sets. A big blank, and they ask you to make this statement true. So what would we need to put here in order to make this true? Is this going to be a union or an intersection? Oh, and if it's easier for you guys to hop on audio, feel free to do that. You can turn your mics on. Sometimes people find it easier, but sometimes people just prefer to use the chat. So either works by me. Just do whatever makes you feel more comfortable. Yes, this is going to be a union. And the reason being is that it includes all of the different components of these sets. 1, 2, 3, 4, 5, and 7. Whereas if it was an intersection, what would the intersection of these two be? What numbers would it contain? Definitely contain a 3. Would also contain a 1. All right. Let's also think about problem 4. So if U is the name of the set is equal to 1, 2, 3, 4, 5, then what are we looking for here? First of all, what does that bar indicate?
The bar indicates the complementary set.
Exactly. So what are the components of the set that I'm looking for?
Well, 1 and 2 are in the set, so the complements within the set will be 3, 4, and 5.
Exactly. Perfect. All right. Let's go on and do a couple true-false type statements. I'm going to go ahead and write a bunch of them out, kind of to start with, just so that it takes a little bit of the writing out of the way. And if my handwriting is ever unclear, like I just saw this 3 looked like that bracket, just let me know and I can definitely rewrite anything that needs to be rewritten for clarity. Because the important part is that y'all can understand and read what's happening. Okay. Let's start by thinking about these. For number 5, true or false, and why or why not?
True.
Okay.
Because it contains all the same elements. They're just in a different order, which doesn't matter.
Yes. For number 8, what's going on with number 8?
Number 8 is false because they're supposed to be equal, and 6 is not in both sets, and neither is 9.
That's actually a 4, unfortunately.
Oh, okay.
Again, handwriting thing, sorry about that. It is good to, a lot of the times I do write what I write down so that people can follow along in the video afterward. So just take a peek at your book. I did this earlier in a different session today. I drew a really bad graph and everyone was very confused by my bad graph because we were working off the bad graph instead of what beautiful graph was in the book. So just an FYI, sometimes it does get a little wonky and I'm sorry about that.
It's okay, thank you.
So 6 is not in set 1. Is there something that we could say that would make sense here? I guess what I'm getting at is the first set
the first set, the subset of the second set?
Exactly. I'm just
could also say the intersection of both sets is 2, 4, and 8.
Exactly. Perfect.
And the union of both sets is 2, 4, 8, and 6.
Yes. So there's a lot of things that we could say about these sets. It's just that we can't say that they are exactly equal. Okay. Now, what about 7?
No, because they don't, neither one has all of its elements in the other set, so neither one can be a subset of the other.
More specifically, we are looking for A here is contained within B. So we would have to make sure that all of A was inside of here.
And since 7 isn't, it's false.
So it is false, exactly. Okay. Let's try a couple more. That is 2, 3, 4. And I also would like to do, this is why I can't use regular brackets, because we use regular brackets. Okay. What are you thinking about 11? True.
Well, the intersection is true, yes. 2 is in both sets. And it's the only element that's in both sets.
Yes. So how I would break this down, if you kind of remember your order of operations, I would kind of think about it almost like that, is that I've got 2 things that are happening here. I've got these sets, we're looking at the intersection of them. So I would just go ahead and write down what the intersection of these 2 sets is, and it's 2. And now I would say, is 2 the set containing only 2 equal to that? And it is, so this is true. What about number 13? Here they kind of did it more explicitly with the brackets. What are we thinking about here?
Well, again, the intersection, if you do the first part of the operation, is 4. And 4 is equal to 4.
Indeed. So A is contained within B. 4 is contained within the next subset. Is this a, actually, I have, sorry. Would I be able to say, let me phrase it like this, that rather this is a proper subset of 4?
No.
Right, and why?
Well, because the only thing they have in common is the element 4.
Exactly. And if the only thing they have in common is themselves, then they are not going to be the proper subset. Okie doke. And let me quick finish writing out what 14 is. It is 1, 2, 3, and 4. All right, what are we thinking about number 14?
Yes.
Awesome. Let's just break it down in the exact same way. Here we've got a union. So our basically rewritten version of this is we get a set that looks like that. And it is a subset of this. So that would make it true. Okie doke. Let's go ahead and practice writing some of these expressions as single sets. So basically, we're given something, and let's find out what it's equivalent to. Let's do 17. Let's do 18. And 20. All right, for 17, what are we going to do and what is our answer going to look like?
17 is going to be the set of 2 and 3 because they would be both elements contained in both.
Exactly. We've got 2, we've got 3, 2, 3, 1, 4, and 5 are not in both sets, so they would not be contained in the intersection. What about number 18?
18 will contain 0, 1, 3, well, 0, 1, 2, 3, 4.
Mm-hmm. And 21.
The null set?
Exactly. So there is no commonality between these two sets. There is nothing intersecting with them. If we were to draw a Venn diagram of this, what would it look like?
I'm not sure. Would it be 2 circles that don't touch, or would it be 2 circles where the line touches but doesn't overlap?
I would say that there were just 2 circles that didn't touch.
Okay.
That would put it right.
I'm sure you're right. That's why I posed as a question, because I didn't honestly know.
Oh, did you actually post that question?
Well, no, posed it.
Oh, yes. Yeah, I would put them as
Just
2
to be
circles.
clear, and I'm visually impaired, so that's why I took the option of turning the microphone on.
Oh, yeah.
It takes me much longer to type and write than it does to speak. So.
That's why the microphone's
And it takes me longer.
Totally an option for y'all. So,
if you've ever tried, like in one of my classes, I have an electronic textbook, for example, in my statistics class. And so Microsoft, well, all computers do, but I'm using a Microsoft computer for these 2 classes, has an accessibility thing where it will read it to you. And but if you were to listen to that and see the pace that it goes much slower than if you read silently. But with me, the pace it goes is literally about as fast as I can go with my limited vision in one eye. Just to give you an understanding of who you're teaching. That's all.
Okay. Well, thanks for letting me know.
I haven't had math in 30 years, but so I very much appreciate this help.
For sure. Let me know if something isn't legible.
It's all good so far. You
Okay.
know, one time I missaw the 4, but otherwise it's fine. I was lucky. I went to Best Buy and had a little bit of my loan money and asked the guy, look, I told him my problem about vision. And I'm like, what can I do? And he says, well, first off, forget computer monitors because they don't go that big. He said, let's go over here to the 4K TVs because they have double the megapixels. And also when you go bigger, things stay clear. And he found one on sale for, it was less than $300 and it's 40 inches. And so that's what I'm looking at right now. So for example, your numbers, if I were to hold up a ruler, are close to probably 3/4 to an inch big, which is what I need. And so it's perfect. Thank you.
Awesome. Awesome. Well, if there is an issue, just let me know and I'll make sure to get that fixed.
Thank you.
Let's go ahead and do number 25. So we've got U is equal to the set 0, 1, hold on, a little too fast for myself, 2, 3, 4, 5, 6, 7, 8, and 9. And then we have two sets that are defined as A, which is 0, 1, 5, and 7, and B, 2, 3, 5, and 8, and then C, 5, 6, and 9. Now we have a series of tasks, essentially, to evaluate each of these, working with the same set of sets. I'm going to color code these, actually, as follows. Okie doke. So for part A, we are looking for A union B. Then we're going to look for the intersection of B and C, and then the intersection of A and B. So let's start with A. What is this going to look like?
0, 1, 2, 3, 5, 7, and 8.
Yes. And the 5 is going to be in both of them. What about B intersecting with C?
5 again.
Yes, and only 5. And A intersecting with B?
5.
Okie dokie. Now let's think about D. Here we have a conflict. That's B, sorry. Okay, so what are we going to look at here? We've got the complement, right, of the set A intersecting with B.
So it'd be 0, 1, 2, 3, 7, and 8. Everything that's in answer A except for the 5.
Rather, would it be okay? So we've got our universal set, right?
Yeah.
Hang on, did I write this down wrong? Give me 1 second. I'm sorry. I'm wondering if I wrote this down wrong now. I did. Okay. Sorry. Give me just 1 second. What did you say it was?
Well, answer A except for number 5. So it'd be 0, 1, 2, 3, 7, and 8 because it's not the intersection, which is 5. So it's everything else in the universal set except for 5. Correct?
Yes.
Not.
Yes.
Okay.
But the universal set is not limited to what we have in problem A, right? The universal set is what we have up here as U. So instead,
yeah, I was thinking just including the because A and B are all that are shown in D. I was forgetting about everything, thinking I was supposed to forget about everything that was in C, but C is a part of the universal set. So yes, so it will be everything in the universal set except for 5. So it'll be 0, 1, 2, 3, 4, 6, 7, 8, 9.
Exactly.
Now, thank you. I'm sure I would have made that mistake on a quiz or test asking the same, even with different elements.
So yeah, basically what we have to do when we think about finding complements is we always have to like compare it back to the universal set, I think, because it is the elements that are not in the original set and yet are in the universal set. So having that you defined at the beginning was like the important like aspect of this particular problem. So let's also do E, which is the intersection of the complement of A and the complement of B. So how would you go about doing this?
Well, Sean's answer was correct. I was just waiting to.
Oh, I'm so sorry.
It's okay.
The chat, I wasn't even looking at it. Okay.
At least I think it was correct.
Yes. Okay. So I saw your answer for B, and your answer for E is the 4, 6, 9, right? I believe that is also correct. But let's work through it just to be sure. We have the complement of A, which is going to be 2, 3, 4, 6, 8, 9. The complement of B, I'm actually going to do that in blue for consistency, which is 0, 1, 4, 6, 7, 9. And now the question is, where do these intersect? And they intersect at 4, at 6, and at 9. So you're exactly right. Sorry, I'm not like looking at the answers right now. So when you come at me with like an answer that is totally right before I've solved it, I can't just like say, like, look at that and say absolutely. Because I, for one, work through problems fairly slowly. So that's not C, that is not C at all. I don't know why I wrote that down. Sorry about that. But that is the answer to E. Okie doke. Now I'm going to quick erase some of this. Actually, I probably don't want to do that. Could be useful for later. I'm just going to squish my book a little bit. And next, let's take a quick look at F. So we have A union quantity B intersecting A. So let's do what's in the parentheses first. We have the intersection of B and A. Have we already done this?
Which is 5.
Yes. Because we did up here, we did C, the intersection of A and B. The intersection of B and A should be the same because it is the points at which the elements within the set at which they share. So I'm going to rewrite this as A union with 5. What is this going to equal?
A.
Exactly. It's just going to be the exact same as A. Let's think about C. Not C, G. G, which starts with C intersecting A, and then that's another intersection with the complement of A. So, C intersecting with A, what does that look like?
5.
Now we are going to intersect with the complement of A, which we wrote up here. Any intersection? No, exactly. All right. I'm going to erase just a little bit of this so that we have space to do part H. Here we have the quantity A intersecting B unioned with B intersecting C. We have done some of these before. Here, A intersecting with B. Oh, that's BC. Here we have this. So that's 5, we know. Unioned with, what is B intersecting with C?
5 again.
Just 5.
B, so.
Oh, we did, actually, yeah. So what's our answer?
5.
Just 5. And there we go. All right. I just have 2 kind of follow-ups, basically, to D and E. Do you remember De Morgan's properties?
Mm-hmm.
What would just like kind of state De Morgan's properties for me? So if I have A intersecting B, what else is that equal to that may be useful?
The complement of A and the union of the complement of B.
Exactly. And then over here, what would De Morgan's property say about this?
It's equal to the complement of the intersection of A and B.
The intersection or the union?
Union, I'm sorry.
Yep. Alrighty. Any questions about 25?
No, that was good.
Awesome. All right, let's do a couple of these Venn diagram ones. Let's do which ones would be good? I think we should do, let's do 33. where we have, use the same sort of color scheme. We have A union B intersecting with A union C. Okay. So, first of all, how are my kind of like circles going to be arranged? And how many of them will I have if we're doing a Venn diagram?
3.
Definitely we'll have 3. I've got 3 sets. I'm going to call that one C. I'm going to call this one B. And I'm going to call this one A. And it's not the most even of overlaps, but I think it kind of gets the point across.
Mm-hmm.
So now I need to shade in. First, let's identify A union B and A union C. So, or you could just go ahead and tell me like what you're thinking. Like walk me through your thought process for shading these.
Well, no, I was just curious because in the some of the video practice lesson, the professor chose, instead of shading, to use different colors, but to use angled lines to show the difference. And I didn't know if that might possibly be easier, not only technically, but easier on the eyes in a sense with what you're working with. That's all. So like if you were to shade in the union of A and B in purple, because A is red and B is blue with purple diagonal lines and so because the union, it would be all of both those 2 circles, not the intersection. It would be all of it.
It would be all of them, yeah. You're right. Let's see. Is there a way that I can do this? Sorry. Is there? Okay. I think there is. I think I can.
When we're done, can I ask one question about how to do something that's totally to do it with what we're learning in the lesson, but
absolutely
different problem? Okay.
For sure. Okay. So there is my A union with B. Yeah?
Yes.
I didn't realize I had a shading tool, so that's why I'm kind of doing it like this, but we can definitely do it in different colors.
But I didn't know you did either. That's really nice.
So let's call...
Go back and forth, or make, you know, which would be really tough to make it solid. What are you, is Zoom providing the tools?
Yeah, this is a Zoom room, and this is just the whiteboard in Zoom.
Cool. Yeah.
So, yeah.
I was asking because I didn't know if like you were using the Zoom room, but you're using Google Docs, or you're using the Zoom room, but you're doing using Word, or some other program that I haven't, or like Minitab that we use in some classes. So.
No, this is all on Zoom.
Good to know, because we use Zoom for lots of things, not only within school, but lots of organizations outside of school use it too. So it's a skill that we can transfer on to our.
Indeed. Yeah, I think Zoom is really handy. I use it instead of Skype now. So that actually I kind of hate. I don't like using the brown. We're going to use a color that's not brown. We're going to use orange. I know that doesn't really fit, but
it's fine.
I think it will contrast well with the purple.
Mm-hmm.
So
much better.
There is our orange. And here is another orange. All right, so now we have all of these unions identified. Now we need to find the intersection of these unions. So where would that be?
Well, it would definitely be the triangle in the dead center.
Mm-hmm.
And I mean, wouldn't that be it? Or I mean, because the overlaps don't include everything. And we're asking for
overlaps do not include everything. How about if I go through and do it in, so orange, and orange's complement is blue, right?
Yeah.
I took art once. And I'm just going to go back and do this in blue instead of in orange. So here we have circle A is filled and circle B is filled, correct?
Mm-hmm.
Then here we have circle C and circle A. So the overlap is not just at the center, right?
Well, the overlap of both.
If we visualize this.
Because so it will be the whole tripod.
Yes. So we've got the entire circle A.
Because we're only dealing with two of the colors, not whereas it throws you off because there's three circles. So you
three circles, but there's two colors.
Two elements in a sense. Because there's two sides to the equation. So yeah.
Exactly. So if we had like algebra here, if we had numbers, we would be able to break this down into this is the blue, and these are our numbers, and this is the orange, and these are our numbers, and we would be able to very easily find the intersection between them. When we're looking at these big old circles, it makes things a little bit more difficult. But we do know where, sorry, my voice is cracking for some reason. We do know where there is some intersection, and that is the entirety of circle A, right? That's all got both a blue circle and an orange circle in it. And also this part here has both blue and orange in it.
Oh, yeah, that's true. I didn't even think about that part of A,
So I'm going to do this in
it's a really good problem because
green, I guess. I think that might contrast well. So we've got all of this. That is both colors, and then also over here.
Yeah.
So is it the best art in the world? Maybe not. But I think we can pretty well visualize what this intersection looks like.
Yeah, and concept and how easy it is to get caught up in the
minutia.
Wanting it to be different from what it really is.
Mm-hmm. Okay, what was your question?
Well, question 25 brought it to mind. But, okay, because I'm involved with not only my major, which is energy and sustainability policy,
mm-hmm.
but also I'm a member of the UNA USA, which anyone living in the US, you don't have to be a citizen, can be. And the United Nations Sustainable Development Solutions Network is somewhere that I not only like to work for or work with NGO or something or
mm-hmm.
member of Congress, whatever, somebody that does. And so the whole world has agreed on 17 global goals. And did that quite a bit ago, 2015. And no one's tried to leave that particular voluntary treaty. And well, within those global goals, which are 17, so that's quite a few possibilities when you talk about the combination of sets and so on and so forth,
mm-hmm.
and everything. There are certain goals that if you don't reach that particular goal, it's literally impossible to reach any of the others. And one of those goals that doesn't always jump out at people right away. I mean, people realize if we don't have sufficient fresh water, we can't reach the other goals because we can't live without sufficient fresh water for the population and clean air. It's not always obvious that sufficient action of climate change is one of those goals. That's key, or achieving peace, but partly because, oddly enough, even though our country only leads the world in three things: incarceration percentage of the population, and we incarcerate a higher percentage. We have the worst income to debt ratio, according to the CIA World Factbook. And we are actively involved and engaged in military conflicts in more countries than any other country. So even though we may have peace within our borders, relatively speaking, if you don't include domestic terrorism, we are not at peace. We're the furthest from it. So that being said, goal 5 is the one that usually people don't realize is integral to every other goal. And that's gender equality, equal opportunity and equal rights and equal pay for the same work, equal access to everything else, the fresh water, sanitation, innovation, so on and so forth. So it's integral in all of the other goals. And I keep looking at different ways to layer the goals, because you can separate them into the 3 sustainability spheres. The one sphere being our environment's biocapacity, the other sphere being things that have to do with the social good or civil society, and the final sphere being the economy, which should really be the smallest sphere, and the social sphere should fit inside the other sphere. Whereas in reality, from 1970 is when the population was about 3.7 billion people, and we crossed over the planetary boundaries, and all the countries have agreed to, and they have all agreed that the textbook for that is Big World, Small Planet, written by Johan Rockström and Matthias Klein, and everything. So how to illustrate when that 5 is a union or intersection of all the other 17, and how the goals that are in the sociology sphere or civil society sphere should be a subset, even though they're not the same elements. They're elements that are dependent on the elements in the environment and biosphere. Without the elements in the biosphere, none of the other elements can exist. Civil society functioning, where people are getting educated and skills and have access to sanitation and the other things. You can't have a functioning economy, which is actually the smallest of the spheres. Well, it should be. But because we're doing things economically that aren't sustainable, and we overshot the Earth's ability for it to produce its renewable resources, and also for its biosphere to absorb the impacts. And by that I mean, because of many of the things we do, we're in the 5th or 6th extinction period. So every time you take out a living organism, a certain part of the biosphere collapses a little bit, or is diminished anyway, because you're taking away what something else relies on. And so if it was a house of cards, like a scientist,
how to show dependency,
they'll collapse. So how to show dependencies, even when they're not the exact same element, but the elements depend on the others. And also how to show one action causes multiple reactions. And not all the reactions are positive, but they're not all negative many times too. There's a combination thereof, and it's determining which is a net positive, and when can the negatives be either eliminated or are acceptable. And it's also complex. But I'm positive that between the skill sets in this class and statistics and there's an emerging way to be able to visually show this to people who aren't as fortunate as us to have the education. To make a poster that anyone with, let's say, well, hopefully anyone, but at least, a primary school education, but even people who aren't, could look at it and the poster would give them meaning, even if they spoke a different language, because what you would choose to represent things, if you look at the global goals, they have a symbol for each goal that has universal meaning across, well, they made an effort to try, hopefully it does, across all cultures. And every country put forward what they thought the symbol would work for their country, the same as smartphones try to do. Every app and everything has a symbol, so that even if, no matter what language you speak, that, like down here, that the chat, that little circle with the line down, that it means to communicate with one another, and that the share symbol means exactly that. You're sending something somewhere with the little arrow. And then the participants, people are involved. So how to do that in a way, and you don't need to do it now. I just wanted to pose it so you think about it. So all semester.
Send me an email.
Class right now. So, but I just want to be able to do it long term, because to me that's a skill that we all have to get better at in what I do, because we really shouldn't have a portion of the population, especially its leadership, that deny this reality that the future, our futures, and every generation after us future relies on us getting right.
Send me an email with a link to the 17 proposals or the 17 guidelines, and just basically tell me kind of what you're thinking about, and I will, or just even a reminder email, and I will try to look into a good way to think about that in terms of the
go on the classes discussion board. You know how we have that?
Oh, the discussion board. You've been talking about it there.
I left this on there basically.
Okay.
I might have gone on a bit more, trying to get the point across, and then below it, I left links to the Footprint Network, because they are the ones that really have illustrated beyond what the Big World Small Planet came up with. So that there's even a calculator there that's not perfectly perfect, but you can put in your own lifestyle choices and see how many planets it would take if everyone lived the way you do, to support them. And so it's also complex because it's fluid, because every day roughly 328,000 people are born and only 140,000 people perish. And so, and every year as we degrade the planet earlier and earlier from the renewable resources, it doesn't regenerate as much the following year. And so, this is a challenge all along with the challenge of the climate change is bringing with it, with the global warming and the extreme weather events and other things. We have to conquer them in unison. And it will take focus for an extended period of time, but we're on there's a stopwatch running that we have no control over, and we can only estimate to the best of our abilities that we have about 10 years left in the carbon budget at current rates. If we cut emissions by half by 2030, that will extend that budget. But If we don't, it won't. And so it's how much it extends it before we go over certain tipping points where we
Yeah.
wouldn't be able
Um,
to learn from for a very long
how,
time. I mean, hundreds of years and things. So it's a matter of communicating it really well to the masses now. I mean, it would have been nice
yeah,
15 years ago, and most of it, the different related links, I'm pretty sure in that post I made,
I'll
I
for
have
sure check that out.
sustainable development goals, and then also things like the We Mean Business Coalition, because a lot of people don't realize that the We Mean Business Coalition is the business world. They manage $22 trillion worth of assets, and they agree with all of this, and they're on board, and they want to make the changes, and but they can't do a lot of it without the support of policy infrastructure that enables leveling of the playing field and accounting for ecosystem costs, accounting for harm to human health when actions are taken that shouldn't be, and so on and so forth. And also, yeah, most of it's in that post, I think. And
Yeah, I'll for sure take a look.
so,
Um, yeah, that would be a really interesting project, actually.
yeah.
I do want to get 7.2 done, though.
Are you on campus?
I am, yes.
Well, if you get a chance to slip in, I think it's sold out, but you still, well, you can definitely live stream it if you haven't already gotten access. There's going to be a conference on campus. I've never been to campus. This will be my first time there. I'm a senior in my major, but I hope to go to grad school. Called Drawdown at psu.edu, and it's research to action, the science of drawdown. So it's taking the science from Project Drawdown, which you don't have to buy the book. You can just look on the website, and the basis is there. Really easy, digestible amounts, but it has awesome bibliographies to what it's all based on, the scholars from 22 countries created, which is very similar to the pathways that the Sustainable Development Solutions Network has also created. And and those scientists who did that are going to be there with our department heads and other notable scientists from around the world, giving sessions on how to take the solutions that we have available now to scale. And it's not just one solution for one problem, it's multiple. And so, I mean, what's going to drive me nutty is I want to hear what everybody has to say, and I'm going to have to pick, because there's going to be like 4 sessions happening at a time. And, so I'll be watching the recorded sessions later, but it's all going to be live streamed, and it's all at the Penn State Hotel and Convention Center. And
Okay.
for
I'll
people
definitely take a look.
having chats afterwards, on campus and different things. And so it's something, and none of what we do works without the skills that are taught in this class. And,
Yeah.
and one thing before I go, I just want to mention, because I think it's important. Our culture many times sees heroes only as people whom are either in the military or the police force or emergency rescue, which admittedly, emergency rescue especially is always being heroic, and police officers and military many times are. Sometimes they make mistakes. But to me, how I define a hero is anyone who, through their efforts, improves the lives of others, and in some cases, that may even lead to saving lives in the present and the future. And to me, any educator who is giving the skills to others for them to be able to reach their goals is improving their lives very, very much so. And think of the thousands of people that attend Penn State every single solitary year, and the thousands at all the campuses, including the World Campus that I attend, that graduate every year and go on in every sphere, not only healthcare professionals, which definitely are saving lives today and into the future, and also, though, people who are trying to solve these enormous challenges and correct and hopefully even reverse some of the mistakes that we've made in accelerating climate change and overheating the planet and leaving what was called anthropocene, I didn't pronounce it correctly, but changing our atmosphere in ways that hopefully we can reverse, but that left us from a very safe spot that we were in for a very long time in the Anthropocene series period, and leading us into an entire different period in history. And so, every day you get the ability to positively impact the lives of every single student. And because you do that, it is a wonderful positive effect not only on them, but on their families and on their friends and on their communities, because they get to be able to become the best version of themselves that they can and reach their own personal goals and be able to become as independent and as self-sufficient and possibly, hopefully even beyond that, to be able to be giving if they get to a moment in strength, even as much as inequality is bad. But there are a lot of people who have been fortunate, who are in the very most gifted and talented sets of school and so on and so forth, who through their efforts chose to take the giving pledge and are giving back to our global community in a variety of ways to help reduce those inequalities and reach those 17 global goals. And they couldn't have done that without finite math.
I love that wrap up. Yeah, finite math is really interesting. I'm not a math major, so a lot of my exposure to this type of stuff comes from working through the classes that I'm asked to tutor for.
What's your major?
I'm microbiology.
Wow.
Yeah, which is not math.
But you rely on it in
all the time, every time. Math is so important to the work that I do.
You totally understand how many times something that is intended to be good can be very bad. Somebody can try and kill what is considered a pest, for example, or a weed, for example. And because they do that, they unintentionally kill lots of healthy bacteria in a soil that help create amino acids and other things that are essential to our well-being, and other things that are used for developing medicines and cures to a variety of diseases that we face that are constantly also evolving and changing and becoming resistant to many of the things that we currently sometimes overuse, like antibiotics being fed to many of our foodstuffs. And so that when we eat a lot of non-organic meat or certified meat and things, we can build up an immunity to many penicillins and other antibiotics that protect us. And all those you understand that complexity.
Yeah, it's a very complex system.
When you certain links,
yeah,
it has a really bad effect. Or that phytoplankton provides a lot of our oxygen. And if the acid levels from the chemical fertilizers and the pollutants create dead zones where there's no oxygen for phytoplankton to exist, it reduces the amount that we have to breathe every breath that we take. And if the number of people are increased faster than the number of trees, which is happening quite easily, again, the level of oxygen quantity in every breath is less, and that diminishes our ability to be in our very best health.
I just this entire time I've been doing thumbs up and nodding and active listening, and then I just realized that I don't have video on, and you would not be able to see the thumbs up that I just gave you. This entire talk, I just
That's okay.
Sorry.
Sorry, I didn't have mine on either because I didn't have the camera.
I gave you a metaphorical thumbs up. You understand the concept.
I do. Well, thank you so much for this session.
For sure. Yes. I hope you have a wonderful evening.
I'm sure I will. I'm going to go ahead and work on the homework now. And thank you because you showed me several places where the equation made you instantly think that the answer is going to be answer X. But if you took the time to really use the Venn diagram or to work through it algebraically, you saw that the answer was
in fact, yeah,
actually X plus Y or something different from what you originally. It was counterintuitive, and so we have to be really careful and think through and take the time to work it out and make sure that we have each part correctly understood and come to the proper result. So I very much appreciate that because I'm sure it will pay off for the entire rest of the semester.
Awesome. Well, thank you so much for coming. Have a wonderful evening. I am going to, these videos have to like process before they're available to be posted, but I will post it like tomorrow. And then I will post a link and that will be available to everyone. So thank you so much for coming again. Have a great night.
May you have a better one.
Thanks.
Thank you.